In order to figure out how high I threw the shark, we're going to have to do some extra work to figure out the quadratic equation. So let's first figure out the height. That initial height is going to be really important because once we have that initial height, we can use that in part of our equation. Just so you all know, I'm 5'10", and so we can convert 5 feet 10 into a decimal by figuring out what's 10 over 12, that's 12 inches, and that's 0.83, which is 5.83 is going to be my height in feet. With this information, we can use 5.83, but I did notice something about my feet looking at this screenshot. I'm jumping a little bit right there, so you may notice that I jumped a little bit. That's just kind of a natural part of me throwing something, I guess. And so let's just round this up to 6 feet. Let's say our initial is around 6 feet because this is an estimation as close as we possibly can. We're now going to move into Desmos because we want to figure out how Desmos is related to this. So if I put in my equation here, I don't know what v is, my velocity, but let's just put in some information. What's cool about Desmos is you can put in a slider, so you can see how the parabola will shift and change the larger the velocity there will be and the higher the maximum will be, which is our maximum height. Remember that the goal of this is to figure out what that maximum height is of that shark that I threw up in the air. You notice my dog is freaking out. So we need to figure out a parabola when it comes to height and time. And so we're going to use this quadratic equation. Negative 16t squared plus v times t plus c. Remember that c is your initial height, otherwise known as our starting height. Either one is perfectly fine. I think the word initial is more used in physics, but that's the initial height. V is our velocity in the sense of it's my upward throwing velocity. It's like how fast am I throwing this shark? And so we don't know what V is. And then the rest of it, negative 16t squared, is going to stay the same because we know that h of t represents the height at any point in time. So if I have like 1 second has gone by, that's how high my object will be. So at any given time, that's where that will be. T is our time. T is representing the seconds that passes as I throw the object. It's a shark. And so whenever we figure out T, we're going to plug in T, our seconds, in for time. We're now going to take what we know, the constant, our initial height or our starting height as 6 feet, again it's approximation, and we're going to use that as well as an equation and something kind of cool to figure out what that volume is. To figure out what the volume is, we can use the time from when I initially throw the shark to when it lands on the ground, because when it lands on the ground, which really is cool about that, is that's the height of 0 feet. What I ended up doing is actually going back and timing myself a couple times until I got a really solid answer of 1.92 seconds for it to go from leaving my hands to it landing on the ground. So I just used my phone stopwatch for that, but basically it took 1.92 seconds. Because I know t, I could plug in t in for my equation, negative 16t squared plus vt plus c. But remember, we know that c is already 6, and now we can also plug in t, which is 1.92 in this case. Now you're going to notice here I accidentally forgot to put in the squared, so I'll show you when I add that back in, so don't forget your squared right there. So I'm plugging in what I know and setting it equal to 0. The reason we are setting it equal to 0 is because that's the height. So when the height is 0, it took the time of 1.92. Notice I put in that squared. So as I'm simplifying this, I will end up with my volume. It ends up being a one variable equation where you can combine some like terms and simplify. Once you have this, you can divide both sides by 1.92 to get a volume of 27.595 feet per second. So now I can actually fill in everything that I have into my equation. So I know my velocity is 27.6, just because it doesn't need to be quite that many decimals. So 27.6 feet per second. And now let's put all the pieces together by writing out our final equation. So h of t is equal to negative 16t squared. That always is the same. We put in our volume of 27.6t and we add 6 to it. So now we need to put everything together to figure out what was that height way up at the top. There are really two ways you can do this. You can just throw this in the graph and find your maximum, or you can actually think about parabolas are symmetrical, and so half the time it took to get to the ground, half the time should be up to get to the top. All I'm doing here is just typing in my equation, and then I'm going to find my maximum. Lastly, if you squeeze the x and y axis a little bit to get a better window for your parabola, you can figure out what your vertex is just by tapping on it. You'll notice that down below I have 1.92 seconds, 0 feet, and up at the top we have our answer. So, when I threw the shark, after about 0.863 seconds, we get our maximum height, and our maximum height is going to be 17.9 feet. And there's my shark.